This here is a floppy. It's an object, it can move data around. Not much data, about 1.4 megabytes. And this is for a high density model. But 1.4 megabytes? Even the OSs that were made when these were relevant were on multiple of these disks. So yeah, 1.4 megabytes is not a lot of data. But what could we fit in 1.4 megabytes? That would actually be pretty cool to talk about for like, I don't know, 20 minutes? Maybe talking about different data types, how they have compression, and you know, just how much can fit on a floppy. Not that. So yes, floppies. Let's get some data on these disks. What is a simple file type we can include on this? Oh, I got it! Do you hear it? It's music. So we have an MP3 file, or its legal name, MPEG-1 Audio Layer 3. Cool, that could mean anything. I'll try to keep this as brief as I actually have spoken about MP3s already. But anyways, reading the Wikipedia article, it says MP3 compression commonly can achieve 75 to 95% reduction in size. That's perfect for us! As we obviously need the files to be as small as possible. So I'll just download, I don't know, one MP3. That sounds like sound. Well, what's the size? What? A 5-minute audio is 8 megabytes? Wait, so that's 1, 2, 3, move that there. That's more than 1 megabyte per minute of audio! That's like 1 minute of audio on a real floppy disk. What about bitrate? Bitrate controls the data. Let's decrease it. So, how do we do that? There are probably different ways to do this that include a GUI, but I'll be using FFmpeg because it gives you more control over the file. So FFmpeg is the program. -I means input, so the input is the MP3. The B means bitrate, and the A means audio. And the 48 is the value for the bitrate. So instead of 320, we have 48 kilobits. And then just the output. Let's render this. And it's done already? That was pretty quick. Let's see the file. Well, it's just a little over the size of a floppy, but that's okay, we can change it later. So the audio is, it's, fine. Not good. It's like, crunchy? Well, since it doesn't fit on a floppy, let's do like a bitrate of, 32. Yeah, it's below the limit. And it can fit on a floppy. Let's listen to it. Yeah, I thought it was kind of bad. When was MP3 even made? 1991. Old software, but maybe it's still getting supported throughout its life. Latest releases from Damn it! Well, it's old, it's audio. It can't be that hard to improve on quality. Well, that's true. There's AAC, which was made in 1997. What? Oh, the latest release was from 6 years ago. That's cool and all, but I didn't use AAC because I kind of forgot it existed. So, Opus. It's an audio codec. Let's use it. Again, I'm using FFmpeg, and all we need to do is add lib opus. That's literally it. And obviously change the file type to opus. But again, that's just it. When I did 48 kilobits, it was just over. So maybe we should do, I don't know, 32 kilobits? Wow, this is like, good. Like, very good. Maybe as good as the original. Of course it's not, but this might be hard for you to hear. But this is like a noticeable less amount of quality and just like, cleanness. Let's do 16 kilobits. Yeah, it's bad. You can very much hear it. Let's do 8 kilobits. Sounds like we are underwater. It loses like every piece of like it being clean. I did have 5 kilobits on Opus. Yep, that is sound. So let's say 32 kilobits is a good rate for Opus, as we get about 6 minutes of audio per floppy. Not that bad, but obviously it's not the best quality. But there is worse. Chuzzle is a video game that was made by PopCap. If you look into files and look for the music file, it's in a MO3 file? What? And somehow it's 600 kilobits? How? And using MPV, it's a 2-minute audio, but it's not compressed, like at all. What is this file? It's an MO3 file. I feel like you could take that from the name of it. And this is an audio file, I guess. It's an audio tracker file, which is very different compared to a normal audio file. Let's open up the MO3 file, and I'll show you what I mean. Look in here, there are many different sounds, but that's not a song, they're just sounds. But here it is, the patterns. Let's take the sounds from over here and make them into a kind of song. And that's why it's really small, because it has raw sounds here. That's the biggest part of the file here. And with the patterns added up, that's about 10 minutes of audio and 600 kilobits. This is twice as big as Opus, but half the size. 20 minutes of audio for a floppy disk. But here's the thing. There are many formats that do the same thing, such as XM and mod files. Again, these use similar formats, such as having samples, but I shouldn't just read about them, listen to them! Yep, that is on audio. There are many I've selected, and what is there to say? They sound like audio and music. But for the main question, how much audio can be on a floppy? So if we take this song here, I think it's pretty complex with all these sounds and stuff. Plus, it has stereo audio. It's 3 minutes and 45 seconds, and for the size, it's 80 kilobits. Now with some complex math, we get a result of 1 hour and 7 minutes. That's like, really good. That is almost as big as some albums that get released today. Anyways, if we use more complex files, that's about 10 minutes of audio for a floppy, which is a lot less than an hour, but it's more complex, that makes sense. And here's the cool part about these trackers. You can include vocal samples, which is just cool. And obviously, it will be bigger. But let's say you don't want a recreation of the audio file, and the music you want to listen to just doesn't have a tracker file with it. What can you do? Well, there is AI. This isn't the AI you're thinking of, or probably thinking of. It does use the same technology, and it's kind of trained in the same way, but for audio, I don't really know. How does it work? I don't really want to just say, don't think about it, just use it. This is actually a pretty interesting topic, but I don't fully understand a lot of stuff that this is about. But all I understand is that the architecture that most AI chatbots, such as ChatGPT, use is a transformer model, and this audio AI uses the same thing, but instead of text, it's audio. There are probably like 100 more things I just forgot about, and I don't understand. Anyways, I'm using TSAC. It's a weird name. Anyways, I'm using TSAC. Why? I don't know. It was the first one that came up, and I can run it on my computer. How do we use it? It's pretty simple. If we look at the README here, it's /TSAC D for decompress, -V for verbose mode, quality mode, which goes from 1 to 9, I'll just use 1 for the first test, and finally the file. There is CUDA support, but since I'm using an AMD GPU, I don't have access to that. That took about 2 minutes to press. I guess it's fine, let's play it. What? Yeah, it's 8 kilobits, but I can't play it. That's true, we need to decompress it. Yeah, isn't that cool? Well, after another 2 minutes later... What? This sounds like nothing to the original. Well, I guess the original isn't like most music. Let's do a quality of 5 then. Now I have to wait 5 minutes for some reason. Hey, it's fully done. And it sounds just a little bit different. It may be hard for you to hear, but the tone is just like different. Just like slightly different. Well, how big is the file anyway? 45 kilobytes. That's like good. Almost as good as like a tracker file. I wonder how it does with a vocal. What? This is the original. Here's the compressed. Which one is which? What about this one? Guess what? They were both the compressed one. Wow! It sounds like the original, but it's only 30 kilobytes. The only question we need now is, how much can we fit on a floppy? So with 30 kilobytes per about 70 seconds, that's about an hour of audio. This is just random, but I was testing out some more like experimental music, but some of the song had this weird audio part, and the AI thought it was like piano, and it kind of sounded like a bad cover for MIDI. Yeah, anyways, let's put this on a floppy. There is a problem. Remember the decompressing? It would take about 2 hours to decompress the whole floppy disk. And I guess having an NVIDIA GPU with CUDA support probably could make this quicker, but we're using a floppy disk, so I don't feel like that's the issue. If audio was a struggle, let's try audio plus another thing, and that being video. So let's have a look at a pretty small video, about 1 minute 30 seconds. I just downloaded this. Let's have a look at the size. 53 megabytes. That's like 40 floppy disks. Well, I guess we have to talk about video codecs and such. This here is a video. It's using AAC audio at a high bitrate, and the video is using codec H.264. You may have heard of H.264. This is kind of like the box standard codec. Almost every piece of hardware supports it. It's pretty lightweight, but it's old. We don't really need lightweight. We need more video per megabyte. For the audio, I will be forced to use Opus because what else audio format is there? I can't use tracker music, or like that weird AI decompressing whatever it was. So if H.264 is bad, why isn't there H.265? H.265, it's like H.264, but it's better. You can see that from its name. Anyways, we are using FFmpeg again. What we need to do here is add libx265, as that's H.265. Well, it's kind of actually not. What? How is 265 not H.265? That makes no sense. Well, it's x265, not H.265. Yeah, I know, a pretty big difference. Could you tell? So, H.265 is a standard, and X265 is an open source project for encoding video into H.265. So they're different, but in practice, not really. But it's interesting to know. So, -B:\V is a bitrate. We could have done something like 130-ish, but I did about 110. And for the audio, I'll be using Opus in mono mode, and have a bitrate of about 20 kilobits. Well, let's render it. It's actually going to take about 30 seconds, and here's the interesting part, it can be less if you use hardware encoding. I didn't use it because supposedly it can make the video bigger, and we kind of need that space. So anyway, what is the space? Why is it 2.6 megabytes? Maybe the limits were too high? Re-render! And why not, let's change the FPS to 30. As the original was 60, it's 2.4 megabytes? That is less than the 2.6, but not less than a floppy. Let's do 20 FPS, and instead of a video bitrate of 110, it's 70 kilobits. And the audio is 10 kilobytes. It's still 2 megabytes? That makes no sense. The bitrate should be the max. Well, it isn't, because H.265 uses VBR, or variable bitrate, which means when something is more complex, it gets more bits, and when something is less compressed, it gets less bits. It's good for compressing something and for it to look good, but for us, that is terrible. We want terrible outputs. We want a hard limit. So I did add a hard limit, but you can see here, it kind of just did nothing. I did stop 3/4 in, just for it to be 1.7 megabytes. Let's just say the last 20 seconds don't count. So let's just watch the video at least. Yep, something is happening here. And this part is a little bit too complex, I feel like. Anyways, how much can fit on a floppy? If we take away about 20 seconds, as we're at 500 kilobytes over the limit, it's about 50 seconds of video. Yeah, that's like, nothing! So if H.265 is bad, why isn't there a H.266? Damn it! I did try to use H.266 with FFmpeg. It's not in there by default. So I had to compile H.266, which is not difficult at all. Just follow some commands, and that's it. The app I used was VVENCAPP. Very catchy. Anyways, -I for input, just like FFmpeg, -R for FPS, and for some reason -FPS is for FPS2. I don't know, there's two of them, okay? I just use both of them. -B is for bitrate, and a rate of 1 megabyte, which we can't even use, because the least we can do is 1.5 megabytes. And wait a minute, 1.1 megabytes? That's like 1 megabyte per second. Huh, let's just render it. Wow, that's fast. We're doing an average of 1.2 FPS, and we have 2500 frames. If it's 1 frame per second, how much is 2500 frames to seconds? About 42 minutes. This is for a 1 minute 30 video. Why? Something is wrong if you can't tell. Well, I guess we have to talk about H.266. How do I put this? This codec is kind of dead. It's one of the best codecs for compression, but like, no video players support it, unless you want to compile the program to include that, but like, many people don't want to do that. That's not good. Also, this is partly due to licensing, which is another problem that can be spoken to death. But all you need to know is that the license is expensive, and you know, most programs don't want to use it, because most people don't use it. But since most programs don't use it, most people don't want to use it. Okay, I think you understand, alright? Oh, and there is an alternative that is actually almost as or even better than H.266. And it's free, as an open source. So people can actually use this one instead of H.266. So if H.266 is so bad, why isn't there H.267? Well, there isn't, alright? It's AV1. What does the AV1 mean? Average Video 1. Nah, I'm just kidding. It means AO Media V1. But that's boring. By the way, yes, H.266 can be better than AV1, but I literally could not test it because it's so slow. Also, it can't do under 1 megabyte bitrate, so Here's a couple things that make AV1 better than H.266. It's free, as in, we can use it without any licenses, so guess what? It's included with FFmpeg. And FFmpeg is easy to use. Well, it's actually slightly different to other codecs, as there's multiple versions of the same codec for some reason. I don't even know. I guess that's just the openness of AV1. For example, I tried the first one that came up on the documentation. libaom is the one that the AOM team did work on, and it was slow. Like 0.1 speed. But not as slow as H.266. But here's the thing, I don't really want to wait for this, but here's a good thing, there's other versions to test. So I used RAV1E, which sounds like a scene group. But anyways, it's meant to be the fastest and safest AV1 encoder, which that kind of sounds good. But here's the question, was it faster than AOM? Yes it was, by about 2x. That's a good improvement. Reading into it is pretty interesting as well, such as Opus being made from the same foundation, which is pretty cool. Also they made FLAC, which is pretty cool again. So after about 10 minutes of rendering, what happened? Yeah, my power went out when rendering, and I'm not rendering that again. So I'll just look at this faulty video here. Yep, it's under that 1.4 megabytes. But some stuff here is like a tad glitchy. Also, it's not looking as clear as the original. But we do have another AV1 version we can use. AV1 SVT, which is actually the one that Netflix made with Intel. And then AO Media, they use it for a base for any other AV1 developments they have. So yeah, it must be the best one. So again, I'm going to be using 24 FPS because we need to save space. And let's do 60 kilobits. Why? Why not? So now I'll be back, as you know, the other one took forever, And switching to a different codec shouldn't make it just faster, because, you know, if they're both using the same base codec, that won't make it faster. That's not how it works. How much longer do I have to speak for the rendering to stop? Now? So yeah, this is actually the fastest encoder. Faster than the fastest AV1 encoder. Maybe I was using the wrong settings on the other one, but I guess I didn't use them, so eh. But anyways, with 24 FPS, it was over 1.4 megabytes. Let's do 12 FPS. Look into the logs, it looks like the bitrate is random sometimes. It's sometimes 40, and sometimes 140. That's more than 60. Let's add a limit then. Qmax, which is just bitrate max. Can we just set a 60 kilobytes limit? But you actually have to use a number, not just the bitrate for some reason. I don't know why it works like this, alright? But I used 1 because lower the number should mean lower the bitrate, right? That's a little bit more than 60 kilobytes. Oh, because the higher the number is, the more restrictive it is. And the max is 63 for some reason. I'll just use 63 then. And it worked. We are like under by like 200 kilobytes. That's good. But the video isn't good. But it does make sense. It's a 1080p clip being ran from only 1.4 megabytes. That's like nothing in today's time. See how long it would take to use all that data by being on the internet for more than 2 seconds. But it's cool, huh? If AV1 is so good, why isn't there an AV2? Damn it! There is an AV2, but it hasn't been released to the public yet. Good. But it's meant to be a successor to AV1, which you can probably get from the name, as it can supposedly decompress from about 30% more than AV1, which is, I guess, cool. Since we talked about audio and video, we should probably talk about something with another thing, but here's something cool. Demos. That's more things to talk about. So what are demos? I'll try to keep this brief because I actually have spoke about these before. So demos are pieces of code that people have made that usually can be ran on weak hardware or very small, like 4 kilobytes small. Wait, that's perfect for us! So yeah, I just picked a couple of demos we could look at. Yep, that is a demo. And it's running with so much space to spare. Wow, this one looks like it's more than 4 kilobytes, maybe even more than 6 kilobytes. And this one too. Yeah, I wish there was more things for me to say about demos. I really can't say much about them, as there's not much to do except describing what they are. And I don't really want to explain what is happening here. So what now? We did audio and video. We should have another sense to it. Maybe like controlling it, like a game, or just any software we can control. What's a popular game? Minecraft! I did find a couple of versions of Minecraft that were close to the limit, such as this demo one that was made for PC Gamer, but it's about 5 megabytes. Damn it! And before you say it, yeah, you can't just remove the sound or textures because the main executable is 2.4 megabytes. But maybe you're like, oh, what about the classic Minecraft website? Well, the main HTML file is 10 kilobytes. That's good! Oh, well, we can't use it because it needs a JavaScript file, and all the code in the JavaScript file is 3 megabytes. Damn it! But again, you may be like, what about Minecraft 4K? Which was the edition that Notch made for a contest, where the game had to be under, how big it had to be again? What was the size again? 1.3 megabytes? Oh wait, no, it was 4 kilobytes. Oh, I feel like 4K meant picture quality. So the backup of Minecraft 4K was just taken down. Oh. Yes, there is a modded version on the archive, but I don't really trust this person. And the original was taken down. And it was probably Microsoft taking it down because, you know, Microsoft things. And I feel like we aren't missing too much. Yeah. So one more version to speak about, which isn't Minecraft, but is Minecraft. Huh? Classic Cube is trying to emulate the classic versions of Minecraft. Just like the browser one! Just download Classic Cube from the website, extract it, it's 1.6 megabytes, damn it. But the main executable is 1.5 megabytes. Ah, so there must be the textures taking up all the space. Only 80 kilobytes. Huh. It must be the sound taking up all the space. What is the bitrate of these sounds? 512 kilobits. Yeah, let's transcode these with FFmpeg. I do want to use Opus here, but since it's in a WAV format, we should probably keep them as is. I made a simple script to turn all the WAV files into a directory into a lower bitrate. That was quick. How big are the files now? Okay, we don't need sound anyway. We are under 1.4 megabytes. Let's see the game. Download? No. Yep, that is classic Minecraft. And yep, that's a purple gem from Bejeweled Tree. Well, it does everything it says in the box. So I was looking at some games that could fit on a floppy, and by doing this, I just searched up games that could fit on a floppy. But every game I could see was for DOS. And if you don't know what DOS is, it's like an operating system, like Linux or Windows, but it's completely text-based, and it's completely different to Linux or Windows. Even though Microsoft made a DOS version, and many old versions of Windows were built on top of DOS, 95 and 98. Anyways, these games can't be ran natively, except if you're using Windows 95, but newer versions of Windows kinda need an emulator. A good DOS emulator would be DOSBox, but if you look at the size of it, it's over 100 kilobytes over. Wow. I did try to compile it, because I thought it might make it smaller, but after doing this it ballooned to over 100 megabytes. So no. DOSBox is an open source project with many forks to use, such as one that is 20 megabytes, or one that is again 20 megabytes. But there is a portable one that is 2 megabytes. Damn it, man! What about instead of installing a DOS emulator on the floppy disk, we could just have DOS on the machine? That can be possible because DOSBox can't be run on floppy, so how would a whole version of DOS run? Well, I guess we can just try it. I've used FreeDOS before, which is just a fast version of DOS. But no, DOS is over 40 megabytes. Oh wait, never mind, this is a floppy disk version. Well, we have FreeDOS on a floppy disk. It's very simple to install. Just set the floppy disk. I'm using a USB floppy disk adapter. Find the virtual mount point, LSB and now dd if the FreeDOS image of /dev and then the floppy disk. And now we wait. I did try this with a couple of disks. One was outputting this error, which just means it can't read itself, which probably means a bad sector. Isn't that cool? But I'm just using some Sony ones. I'm pretty sure these weren't used either. Also, they were Japanese for some reason. Anyways, we have FreeDOS on a floppy. Let's try to boot it on real hardware. Not just some phony virtual machine. This here is a ThinkPad. X131E. I could have used some other computers I have, but this laptop is small and I don't really want to bother with hooking up a desktop. So anyways, adding USB booting to BIOS, and let's give it a try. Yep, we have to wait a little bit. And again, yep, it's FreeDOS. But we can't do anything. We didn't install anything. We do have 80 kilobytes to spare on the disk, so we kind of need a smaller game. Lemmings! They look small. And it is small, about 700 kilobytes. That's perfect for us. And run the bat file. Hey, it's working. That's a first for me. Anyways, let's get into game. I can't do anything. The trackpad isn't working. Maybe a wild mouse? Nope. I think the issue is that I just don't have a mouse driver, but I have no idea how to install one. Maybe I have to look for a game that actually doesn't need a mouse. Well, this isn't a DOS game, but it's kind of a flash game, which is like small, under 200 kilobytes. And it's Bejeweled? And something like Plants vs Zombies is only 40 kilobytes. Yes, these are both demos, and flash versions of these demos. But they're still games, and guess what? They run good. But we just can't run them as they use outdated coding frameworks that aren't supported anymore. But there are open source alternatives to them. Like Ruffle. How big is Ruffle? What? That's like a lot. And the sad thing is, I couldn't find any software that appeals to me. Which kind of makes sense as this is kind of a niche topic. I don't feel like there's that many people making a flash player that can fit on a floppy disk, plus have enough space for the game. So what about DOS games again? Commander Keen. Yep, it's Keen on a floppy, and it's only 200 kilobytes. But what? Out of memory? How? We have 8 gigabytes of RAM. There's probably a fix for this, but how do I put this? Games for a floppy disk aren't that interesting as yeah, they work, but we can't really compress them, and talking about compression is pretty interesting to me. Well, there is like generic compression like 7-zip and Tarball, but with something like 7-zip and with a game like Lemmings, it takes about 700 kilobytes to 600 kilobytes, which is more than a 10% decrease. But like, yeah, I guess it works, but there's not much to comment on. Wait, we should probably talk about text. No! What's the thing that takes the most amount of space on a computer that the user didn't install? I know! The OS! Let's get an OS on a floppy! There's FreeDOS, but I feel like you could tell this would run on a floppy. Let's go on a hunt. So here's some older one, QNX. This was made in 1998. That's like a long time ago. Huh. It has a couple of programs such as a vector animator, a notepad. It has a program that just says QNX is cool. Cool. Extensions for the demo. That's cool. And some games that are running on a basic web browser. That's cool. Just not much to comment on. So maybe I can comment on something like Calibre OS? Look at this, it was based on a different OS called Mentu OS. There's something weird and funny about this OS, is that the 32-bit version of it is open source, but for some reason the 64-bit version isn't? There's like no reason to do this. I'm going to be using Calibre OS because it has more apps pre-installed. So again, it's actually a really easy install as well. Use DD, that's it, and boom, done. Here's some interesting things about this OS. It's not Linux, or just like any Unix type. It has its own kernel that is built on assembly, and you know what else is coded in assembly? The whole system. Yes, every single piece of this operating system is built in assembly, but we really don't need to know that much about it. We need to see the system. That is a lot of dots. Well, that is something. Sure, to whatever this means. What? Loading from diskette, and it's about 1% per 1, 2, 3, 4, 5. More than 5 seconds? Well, I guess the OS must be pretty compressed then, but that's the reality of using floppy disks. And 10 minutes later, 10% more percent needed. Oh, okay. Well, look at those choices. Minesweeper? Yep, that's Minesweeper. Game Center? That's a lot of games. Pong 1? Yeah, nah, I want Pong 2. Well, it doesn't exist, but there is Pong 3. Yep, that is Pong. But like, you can punt it? Okay, sure. Wow, look, a file browser. Yep, that is a file browser. And that is a song. Wow. I don't know what to say. Everything here is pretty impressive, like, just everything. And it's all written in assembly. Like, that's crazy. A web browser? And for some reason there's 2 of them? Oh wait, I need to download one of them. Well, there's one browser, which is crazy for only 1.4 megabytes. I could probably talk about this OS for a different episode, but all you need to know is that this OS is impressive, and that's, good. Oh, that seems like everything a floppy could hold. Wait, we haven't really spoke about what they can hold. We haven't tried them on real hardware. Well, the thing is, that's boring. As in, nothing will happen except long load times, or it just working fine. And, that's boring. I think this is everything we could speak about floppies that they can hold, or probably not. But imagine the possibilities that a floppy can hold. Videos? Files? Other files? 1.4 megabytes of data?